Hey guys, I just want to do a little follow-up video on the whole resistor divider networks for the voltage meter. It's right here. So when we do the math, we get our division ratios. And the math works out great. But the reality is that resistors are just a little bit more complicated than that. Because you have to get not only exact values for these resistors, but they have to be of such precision that it's difficult to obtain. And what do I mean by that? Well, these are 0.1% resistors. It's 0.1%. And in the whole resistor stack, I've got 100 kiloohms. Really 100 kiloohms. What I didn't realize, or what I underestimated, was that to get real meter accuracy, you're not looking at 1 part per 1,000 or 1 part per 10,000. You're looking at parts per million. And so in buying lots of resistors and sitting lots of resistors, for those of you who don't know what a sit is select and test. So I have a little grave here for all my sit resistors. They're still good, but seeking this kind of precision, you can see I've even resorted to Kelvin clips to ensure the precision is met here. And technically, it's still not there, because when I switch between ranges, I still don't have the precision that's desired. And that's because I'm using a whole network of resistors that's common. So with these meter modules, you get basic accuracy. You have this trim pot back here that adjusts the VRAF on board compared to this voltage. So this VRAF is comparing 100 millivolts to the 200 millivolts that comes in to the circuit. And the meter here on this guy is relatively accurate, and that's compared to this meter, which is really accurate. I'd like the basic accuracy to be there. We're not meeting it because we're going through two different ranges. And we're going through a series of resistors. 100 for the higher range and 900 for the lower range, I believe. Or I might have that backwards. Yeah, okay, so it's, yeah, don't worry about it. You guys probably gonna build the circuit anyway. I'm me pause it real quick. Let me see what I can do here. Let me see if I can get that to match up. Yeah, it's just not going to match up no matter what you do. So really, there's a couple ways to go here, which you could go with. I didn't want to use trim pots because resistors are more stable. But you can see I'm not getting the precision that I need. So what good is it? So I have to rethink this a little bit. There's a couple ways to go about this. One way, of course, is to use 2 strings, 1 string per range, and that wouldn't be too terrible. I could use trim pots for that, and I could dial it in, and I can get the precision that I want. It'll be some drift, but it would be more precise than being off by 250, 300 millivolts. So I could do that. I could stick with 1 range only, but I would compromise a lot of the precision that I want to show. I'm not really able to show the precision that I want at the moment. This is a fun idea that I wanted to pursue, but it's not quite working out right now. So 2 strings is one way to go. Pots would be another way to go. You can do that. You can do a resistor in a pot, or 2 resistors and a pot in parallel with the resistor to trim it, which would add some stability because there's a resistor there that's fixed, and the pot would just be there to shunt the resistor to dial it in to get your basic accuracy that you're looking for. So I'm going to have to rethink the current circuit, because the current circuit also uses a string of resistors, and unfortunately I've already drilled the board for it, so I'm going to have to rethink that a little bit. There's another option which I'd like to avoid, but I've already spent a ton of money on resistors because I thought this was easy, and that option is to buy a precision resistor module that has the resistors already in it, and those are designed for meters, and they're expensive. I've already wasted plenty of money on resistors, and these, they're not too bad. They're anywhere from 49 cents to $1.15 a piece. So that's a lot of money for a resistor. But the precision resistors for meters cost $80 each. So I might purchase a couple of those to play with, but that would mean the entire board was worth less than the resistor. The cost of the board is essentially the cost of the resistor. So there's that consideration too. This meter may still not have the precision required after that module. We don't know, because we have to spend the $80 to try. So I just want to let you guys know that this is a little bit more difficult than it looks on the surface, because you're switching ranges in a resistor stack. And the other thing which is important is that these the ICL 7107, you cannot share the input ground with the power ground. They need to be separated. So if you tie the grounds together, you're going to short it out. Not badly, but it'll reduce your accuracy. So that's about it. I'm out of time.